Bon après-midi, mesdames et messieurs. Good afternoon, ladies and gentlemen. Buenas tardes, señoras y señores. My name is Sung-Hoon Kim, and I'll be your host for this event. I'd like to welcome you to ICAO's 13th Air Navigation Conference. And this is SkyTalks. We're coming to you live. I'm going to ask you to please listen to our panel of experts. And when the presentation is done, you may step back to the mic and ask questions. Now, those who have not had the opportunity to view all of our listings, please make sure to go on YouTube and type ICAO SkyTalks, and you'll be able to see the full list of presentations that we have for you. Another frequently asked questions that I get is regarding the slides that you see on the screen. They are here to help you with the presentations to understand them better, but for those who would like to view them, please make sure to ask us, and we will send those who belong to us, and for those who belong to private industry, we'll ask the authors, appropriate authors, and then send them to you afterwards. Okay, so this is day 5, session number 23. In earlier sessions, we've mentioned a few times about RPAS and other low-lying flying aircrafts, but technology has not only helped us develop the sub-1,000-meter airspace, but also we were able to fly into the stratosphere and to the exosphere and into space. Now, that brings us great opportunities, and to help you explain more about those, please welcome Yuri Fattah, ICAO's program manager and guru, who is in charge of 3 SkyTalk sessions this year. Thank you.
Much. So those who saw my earlier presentation last week, this one is a lot more boring, so I hope that presentation is not why you are here. I'm going to wait for my slides. Oh, okay, that's... So we have an agenda item 5.1. No, we have 5.1 on Higher Airspace Operations. It's a great way to start a boring conversation. And I'm just here to provide you a little bit of oversight on what the real stuff behind this is. So the overview, everybody wants to know, is this really real? Is this something that's going to happen? Is this, and on Wednesday, I'm going to give another SkyTalk on commercial space. So if you think this stuff might not be real, I'm sure you're wondering about the other one. What's important for us to know as aviation and non-aviation really is what's the delta? What stays the same and what changes? What is different? And in the end, I want to provide just a few insights into how all these new things can inspire all the old things. So my one presentation with pictures, and intentionally so, what you see here is what I think we can all see is it is real. Okay? It's real in many ways. What you see on the top are 2 specific crafts. The Google Loon, I think many of you already know, they already provide services in many parts of the world. They have provided services in response to 2 catastrophes last year, and they're a very mature product in terms of operational deployment. So I think of the pictures you see there, that's probably the most advanced right now in operational sense. But what you see to the left, top, is a solar wing. This is specifically the Zephyr, the Airbus version. There was another company out there who was also developing one, but they have decided to join their efforts with Zephyr at this point. But that's a real picture of something that's flying. Both of these on the top that are already one is testing and the other one is operational. They're already talking about how you do airspace management up in the top where they're going to share. What's important to know is that they provide a service that is normally provided really by satellites. So they provide communication services and mainly in the 3G, 4G network. They're going to stay up there for a while. They're unmanned, one would hope, and probably operationally you can talk about hundreds of days. Their operational altitude is above flight level 600 or 60,000 feet. And right now, I think they are deployments. They're trying to get the deployments a couple of thousand feet above that. What you see on the bottom three, first, the cool-looking one, that's the boom demonstrator. This picture is a little old. They have purchased their rocket for it, their engine for it, and they are serious in the sense that they have hardware and they're going to start testing quite soon. This will be the 4-seater version eventually, and then that's the demonstration piece that will then become a much larger aircraft, for which several companies have already put orders in, at least tentatively. And then in the middle you see the Thales concept of an airship. My understanding is that they are in the process of developing a test vehicle, which will be slightly smaller, but will be their demonstrator. And then on the bottom right, that is a very old picture now. And I think sometimes when you see this, you think, oh, this technology actually has been for a while. I think it was called the Helios. That was a NASA solar-powered demonstrator. But it has, I believe there's a company right now that is looking into using that same technology to deploy it on a commercial basis. So yes, it is real. I think we need to be very cognizant of the fact that the technology is actually not right now needed to be developed, rather the deployment. So what is the same? You've heard this term many times before, and I'm sure ICAO has been asking you as governments or you as operators or whatever, where's your safety management system, where's your state safety program, and all that. So safety management is a concept, of course, that goes throughout all operations. The identification of hazards, the assessments of risk, the allocation of resources based on those risks, and how to mitigate and how to also be proactive with safety. I think you've heard a lot of that during this last couple of days. There is nothing that you see here that's operating that isn't going to be operating with safety management. When these things go up or come down through controlled airspace, they will basically behave to the most degree to the controller, the same way as anything else does. Some things are very slow to react, but it's not like there isn't anything slow out there today. Whereas once they're out of controlled airspace, they might operate in a manner that's not traditional. When they are in controlled airspace, they are a flight like everything else. So the bottom line is that they follow the same laws of physics as everything else. And I think this is very important to realize. Like I say, I also work a little with commercial space. And we need to understand as regulators that there is a threshold at which the laws of man are more insurmountable than the laws of physics. And we need to navigate that boundary in a mindful way. So you cannot expect something to do something that's physically impossible. I think that is very clear, even if something else is doing it. Right? So that is the same. What is different? Like I mentioned, the mission. These things go up, they fly slow, sometimes they fly fast, like the supersonic, of course. Even the supersonic, if you compare it to the Concorde missions, their mission profile is slightly different. But no matter how diverse the missions are from the traditional environment, the basics remain the same, like we had seen before. And in many cases, when it comes to these things that are pseudo-satellites, basically, we have to be cognizant of their mission, because if their reason for being up there is to provide communication services, and then you have an aviation requirement that requires communication services, well, it's kind of weird to have something that is a communication satellite having then to attach to itself something else to communicate to another communication satellite because of aviation. And we've seen in some cases that if you look at the unique identifiability of many of these things, some of these things are part of the Internet of Everything. So then you'd have a unique identifier for the transponder code, a unique identifier for the IP, unique identifier for the Ethernet, so it might be carrying multiple unique identifiers. And the mission might be able to provide a more effective way to satisfy the communication or surveillance performance requirements. Oh, and I went backwards there. Okay. There is always a human in the loop, but it is automated. And automation is a word that we have to be a little bit careful of because it's perhaps not completely defined, and a lot of people are worried that these are robots in the sky. But the system is designed by humans, they're tested by humans. Yes, there is a level of autonomous or machine intervention, and they are heavily monitored and tested. And sometimes we have to understand that the machine may know something the human may not, or the machine may be able to respond quicker than the human may not. So in some particular cases, especially up there in the atmosphere, these things are sensing weather conditions that we on the ground do not know. And they may need to react to that quicker than we are able to figure out what's going on. So it's important to keep in mind that it is, yes, the human is in the loop, but there is a level of automation. The technology is different and it's the same. It's the same in the sense that we're dealing with, they might have transponders on board. They are able to communicate and be part of the network as we prescribe for the rest of aviation. But the technology is also different from the materials they may use to the way they might satisfy certain performance requirements. And what is exciting about the technology is that if they do something better than traditional aviation, that might be a precursor to what we could do with that kind of technology for the rest of aviation. And that's not the first time it's happened. It's happened in our past where we may have had a regulation that requires certain things to be carried physically on board of an aircraft, but then when it came to RPAS, we had to find an alternate means of compliance. And now it doesn't make sense that if something's good enough for an RPAS, it's not perhaps good enough for a human flight. So this technology leaks back into, the innovation leaks back into traditional aviation. Then, as kind of mentioned, because of this thing, they operate above traditional airspace. That is not to say that no one is up there. There are some business aircraft that can get pretty high up, and there are non-civilian aircraft that go up there. So there is some experience, but overall, you're talking about a piece of the airspace that is not actively controlled, managed, perhaps as the rest. So this is really what this all leads into. We have a bunch of companies out there who have budgets and innovation, are leading innovation in many parts of technology. Many of them are not traditional aviation companies, but they are tech companies. And they're starting to do aviation things and are questioning why we do certain things and why we don't do them better or differently. Because they're above everybody else, when they're amongst themselves, they don't need to worry about backward equipping any traditional aircraft. So if they have a different way of separating, have a different way of airspace management, and there is an equipment list for that, they're going to be able to equip themselves for it, and they don't need to worry that there is a large, slow, heavy aircraft up there that's just not able, hasn't been retrofitted to meet those performance requirements. So in the aviation terminology here in ICAO, we talk about blocks, block 0, block 1, block 2, and we talk about certain technologies that we want to deploy in traditional airspace in block 2, and part of the reason it has to wait till block 2 is because of the issue with the traditional planes in that space, right? The older aircraft, they have to rotate out before enough of the population is equipped to be able to perform a certain way. But in this case, You're talking about guys who are right now thinking of how they will manage their separation, how they will work together as a community, and they don't have that constraint. So they are really first adopters for many of the advanced technologies that are technically available today, but it cannot be deployed operationally without much thorough study and trials because of the others in that sector. And so here are a few that you will probably hear of today or tomorrow, or maybe it was last week. Trajectory-based operations, FFICE, and system-wide information management. And I think, you know, one of the issues we need to come to terms with is that in many of these modern things that we write, we can describe the performance, but we have not necessarily been able to say how it can be done. Well, here are a bunch of entrants. Many of them are, you know, IT companies themselves who are able to perhaps develop the solution that meets our performance. And they have the wherewithal to be able to test it. So the real excitement out of this technology, yes, it helps that they provide internet services in cases of disaster response. Of course, that you cannot top, and that the next billion people to be connected to the internet might be doing it this way. But for the rest of us in aviation, we might see them doing things that puts Block 2 and 3 on a fast track. So that's the end of my talking slides. If there are any questions. Okay, well, enjoy the rest of your meeting.